NASA just quietly reassigned the most critical job in the entire moon mission. And they gave it to Starship. Not SLS, not Orion, Starship. The rocket that was originally hired just to land on the moon is now responsible for pushing astronauts nearly 400,000 kilometers through deep space. That was SLS's job, until now. Here's what makes this shocking. NASA is spending billions per SLS launch. Billions. And they just handed Starship the wheel. So what exactly changed? And why did no one see this coming? Here's what really happened. Let's go back to how this all started. When NASA first announced the Artemis program, the plan looked straightforward. SLS, the Space Launch System, would be the backbone, the big rocket, the one carrying astronauts beyond Earth. Orion would be the capsule. And somewhere in the background, a lunar lander would be waiting near the moon to bring crew down to the surface. Starship was that lander. Nothing more, nothing less. SpaceX won the Human Landing System contract in 2021, $2.9 billion. The job description was simple. Get astronauts from lunar orbit down to the surface and back up again. That's it. Starship was the elevator. SLS was the highway. But that was then. Because somewhere between 2021 and now, the job description quietly changed. And most people didn't notice until it was already done. So what exactly shifted? And why does it matter so much? The original plan and why it started breaking down. To understand what changed, you first need to understand what the original plan actually looked like. Under the early Artemis architecture, here's how a moon mission was supposed to work. SLS launches from Kennedy Space Center. It sends Orion and its crew into space. Orion travels to the moon on its own. Near the moon, in what's called near rectilinear halo orbit, or NRHO, Orion meets up with the lunar lander. Crew transfers. Lander descends. Astronauts walk on the moon. Lander returns to orbit. Crew transfers back to Orion. Orion comes home. Clean, simple. Each vehicle does its specific job. The problem? Reality doesn't care about clean plans. First, there was the cost issue. Every SLS launch costs approximately $4.1 billion. That number is not a typo. $4.1 billion per launch. For comparison, SpaceX can launch a Falcon Heavy, one of the most powerful rockets currently flying, for around $150 million. That's not even in the same universe. And NASA isn't made of unlimited money. Congress controls the budget. And Congress has been increasingly vocal about the unsustainable economics of SLS. But cost alone didn't force the change. Something else did. The schedule started slipping. Badly. Artemis 1, an uncrewed test flight, finally launched in November 2022, years behind schedule. Artemis 2, which will carry astronauts around the moon without landing, has been pushed back multiple times. Artemis 3, the actual moon landing, keeps sliding further into the future. Meanwhile, SpaceX wasn't standing still. While NASA and Boeing were fighting hydrogen leaks and delayed timelines, SpaceX was launching Starship test flights, catching booster rockets mid-air with mechanical arms, and iterating at a speed that the traditional aerospace industry had never seen before. NASA was watching. And NASA started asking a question that no one expected. What if Starship could do more? The moment the math changed. Here's where it gets really interesting. One of the biggest engineering challenges in Starship's lunar mission was always propellant. Starship is a massive vehicle. It burns an enormous amount of fuel just reaching orbit. By the time it gets there, the tanks are mostly empty. To reach the moon, Starship needs to be refueled in orbit, multiple times. The current estimates suggest somewhere between 8 and 16 tanker flights, separate Starship launches carrying nothing but fuel, just to top off one lunar Starship before it heads to the moon. Think about that for a second. Up to 16 launches, just for fuel, before the mission even really begins. And NASA knew it. So when engineers started running the numbers on a new mission architecture, one where Orion and Starship meet in Earth orbit instead of near the moon, something interesting happened. The math got a lot better. By rendezvousing in Earth orbit, Starship can take a more direct, efficient trajectory to the moon, fewer course corrections, less fuel burned on unnecessary maneuvers, and that means fewer tanker flights required, fewer failure points, lower risk, better odds of success. But here's the twist nobody expected. NASA didn't just move the meeting point. They changed what happens after the meeting. Under the updated plan, Orion and Starship don't just meet in Earth orbit for a crew transfer and then go their separate ways. They stay connected. Starship performs what's called the trans-lunar injection burn, the critical engine firing that sends a spacecraft from Earth orbit toward the moon, with Orion still docked to it. Both vehicles, traveling together, pushed by Starship's engines all the way to lunar orbit. Let that sink in for a moment. SLS was supposed to be the vehicle that sends astronauts toward the moon. That was its fundamental purpose. The reason it was built. The reason NASA spent over $23 billion developing it over more than a decade. And now, in the updated architecture, Starship is doing that job. SLS still launches. SLS still gets Orion into Earth orbit. But the moment that requires the most power, the burn that actually commits the crew to a 400,000-kilometer journey through deep space, that moment now belongs to Starship. This is not a minor adjustment. This is a fundamental redistribution of mission responsibility, and it raises an uncomfortable question that a lot of people in the space community are already asking. If Starship is launching the crew toward the moon, what exactly is SLS still for? What this means for SLS, the uncomfortable truth. Let's be direct here, because most coverage of this topic tends to dance around the issue. SLS is one of the most powerful rockets ever built. It generates 8.8 million pounds of thrust at liftoff. It can lift 95 metric tons to low Earth orbit in its current configuration. It is a genuine engineering achievement, but it was designed for a world where commercial spaceflight didn't exist at this scale. A world where if you needed something big done in space, you had to build a government rocket to do it. That world is changing faster than anyone predicted. The updated Artemis architecture essentially narrows SLS down to one primary job, launching Orion and its crew into Earth orbit. That's it. Everything beyond Earth orbit, the trans-lunar injection, the journey to the moon, the lunar landing itself, increasingly falls to Starship. But the trajectory is clear. Some aerospace analysts have started using a phrase that would have been unthinkable 5 years ago. SLS as a crew ferry. A vehicle that does one specific job, hands off the crew to commercial systems, and steps back. Is that fair? Is that the right way to look at it? Maybe not entirely, but it's becoming harder to argue against the direction NASA is moving. And the reason NASA is moving in that direction comes down to something very simple: capability and cost. Here's a comparison that puts Starship's role in perspective. The Apollo lunar module, the vehicle that actually landed humans on the moon in 1969, weighed about 15 metric tons fully fueled. It could carry 2 astronauts and a very limited amount of equipment. Starship HLS, the lunar variant SpaceX is building for NASA, has a payload capacity that dwarfs anything that has ever landed on the moon. It's designed to carry over 100 metric tons to low Earth orbit in its standard configuration. Even in its specialized lunar landing configuration, it can carry more cargo to the lunar surface than everything NASA has ever landed on the moon combined. That's not an exaggeration. That's the actual scale of this vehicle. And that scale creates possibilities that simply didn't exist before. When astronauts land on the moon with Starship, they won't be limited to a few hours on the surface with a small rover and some basic equipment. They could potentially stay for weeks, with full laboratories, with large rovers, with construction equipment for early lunar base infrastructure. This is why NASA's interest in Starship goes beyond just, it's a cheaper lander. Starship doesn't just change the economics of lunar exploration, it changes what lunar exploration can actually accomplish. But, and this is a critical but, None of that potential means anything if Starship can't prove it works. The mountain Starship still has to climb. Let's be honest about where Starship actually stands right now. SpaceX has made extraordinary progress. The integrated flight tests have demonstrated orbital-class performance. The booster catch, where the launch tower's mechanical arms grabbed a returning super-heavy booster out of the sky, was one of the most stunning engineering demonstrations in the history of spaceflight. No one outside of SpaceX believed they could actually do it until they did it. But there's a difference between impressive test flights and certified crewed lunar missions. The list of things Starship still needs to prove is significant. Orbital refueling. This is the big one. No one has ever transferred cryogenic propellants, super cold liquid oxygen, and liquid methane between two spacecraft in orbit at the scale Starship requires. The physics are tricky. Cryogenic fluids behave strangely in microgravity. They slosh, they boil off, they require precise temperature management, and SpaceX needs to do this reliably, repeatedly, with hundreds of tons of propellant per transfer. This isn't just an engineering challenge, it's an entirely new category of space operation that has never been demonstrated at this scale. Lunar landing. Starship is enormous. Landing an enormous vehicle on the moon, where there's no atmosphere to slow you down, where the terrain is uneven and dusty, where one mistake means no second chances, is a completely different problem from landing on Earth or even on a drone ship in the ocean. SpaceX needs to nail this, not just once, consistently. Long-duration crewed operations. Keeping astronauts alive and comfortable inside Starship for extended deep space missions requires life support systems, radiation protection, and operational reliability that hasn't been tested under real mission conditions yet. And perhaps most importantly, schedule. NASA has already seen what happens when ambitious programs fall behind. The Artemis schedule has slipped repeatedly. SpaceX moves faster than traditional aerospace, but faster doesn't mean immune to delays. Every one of these challenges is solvable, but they all have to be solved before astronauts climb into Starship and head for the moon. So where does that leave us right now? Artemis 3, the mission that decides everything. Artemis 3 is not just another mission. It is the stress test for everything NASA and SpaceX have been building toward. It will be the first time humans land on the moon since Apollo 17 in December 1972. More than 50 years of waiting. And when it finally happens, Starship HLS will be the vehicle that takes them down to the surface. If Artemis 3 succeeds, the implications are enormous. Every piece of the architecture gets validated. Every skeptic gets answered. The path to Artemis 4, Artemis 5, and eventually a permanent lunar presence becomes dramatically clearer. But Artemis 3 also carries a weight that no SpaceX mission has carried before. This isn't a test flight where a failure generates valuable data and the program continues. This is a crewed lunar landing. The margin for error is essentially zero. And that's exactly why the updated architecture for Artemis 4, with Earth orbit rendezvous, with Starship performing the translunar injection, is being developed so carefully right now. NASA is learning from Artemis 3 before Artemis 3 even happens. Building in redundancy, planning for contingencies, designing a mission profile that gives astronauts the best possible chance of success and the best possible options if something goes wrong. Earth orbit is forgiving. If something goes wrong during the docking procedure between Orion and Starship in Earth orbit, astronauts can abort and come home. That option disappears once you're 400,000 kilometers away. This is why the rendezvous location matters so much. It's not just an operational efficiency choice. It's a safety philosophy. And it reveals something important about how NASA is thinking about the future. There is one more piece of this story that deserves attention. NASA didn't just award a human landing system contract to SpaceX. They also awarded one to Blue Origin, the space company founded by Amazon's Jeff Bezos. Blue Origin's lunar lander is called Blue Moon. And the plan was always for Blue Origin to support separate Artemis lunar landings alongside SpaceX's Starship. But something has been quietly shifting in that part of the story, too. Blue Origin's New Glenn rocket, the heavy-lift vehicle that Blue Moon depends on for parts of its mission architecture, has faced its own significant challenges. Development delays. technical difficulties. The kind of setbacks that, in a program as complex as Artemis, can cascade into much larger schedule problems. NASA has provided remarkably detailed public updates about Starship's Artemis 4 roll. The docking sequence, the translunar injection, the specific orbital mechanics involved. The level of detail suggests a mission architecture that is becoming firmly established. Blue Moon's Artemis roll, by contrast, has received significantly less public attention in recent NASA communications. Does that mean Blue Moon is being sidelined? Not necessarily. NASA hasn't said that, and it would be premature to draw that conclusion based on public communications alone. But in a program where every dollar and every schedule slot matters, the level of detail NASA is investing in planning around Starship versus Blue Moon tells its own story. The question worth asking, and it's a question the space community is increasingly debating, is whether Artemis ultimately needs two human landing systems, or whether one system, at the scale and capability of Starship, might be enough. That debate doesn't have a clear answer yet, but the fact that it's happening at all points to something much bigger than a contract dispute. And that's exactly where this story gets truly historic. The bigger picture. What this really means for the moon. Step back for a moment. What's happening here goes far beyond one rocket or one mission. That's a shift that goes beyond Starship, beyond SpaceX, beyond even the Artemis program. It's a signal about how humanity is going to explore space going forward. The era of space exploration, being the exclusive domain of government agencies with unlimited budgets and decade-long timelines, is ending. Not because governments are stepping back, but because commercial capability has grown to the point where it can take on responsibilities that governments once had to handle themselves. Starship is the most visible symbol of that shift. But it's not the only one. And here's what makes this moment genuinely historic, separate from all the engineering achievements and mission architecture decisions. For the first time in human history, the vehicle most responsible for pushing humans deeper into space is not owned by any government. It's owned by a company that iterates by launching rockets and learning from the results, that measures success in flights per year rather than programs per decade, and that has stated openly that the moon is not the destination, it's the practice run for Mars. That changes the calculation entirely. Because if Starship succeeds at Artemis, if it lands astronauts on the moon, demonstrates orbital refueling, and operates reliably as the backbone of NASA's lunar architecture, then SpaceX won't stop there. The same vehicle, the same architecture, the same refueling strategy, just pointed at a different destination. And suddenly the moon landing that NASA and SpaceX are working so hard to achieve isn't just humanity's return to the moon. It's the proof of concept for everything that comes next. That's the full picture. And the data speaks for itself. If this analysis gave you a clearer view of where Artemis is actually heading, hit like, share it, and subscribe to the Space Brief. We read every comment. Drop your take below.